Hello class, I'm Elizabeth.
I'm Dylan.
I'm Madison.
And today we're talking about
the layers of Earth and their properties.
And how they cause natural disasters.
So first, we're going to start describing the structures of the Earth and its layers. So the Earth consists of four main layers: the inner core, the outer core, the mantle, and the crust. The inner core is made up of an iron solid that is the same temperature as the surface of the sun. The core makes up 1.7% of the Earth's mass, and its distance from the crust is 5,000 to 6,000 kilometers. Just as the Earth's surface rotates, the inner core turns approximately 0.3 to 0.5 degrees per year. Or you can think about it as making an extra rotation every 700 to 1,000 years compared to the surface. The next layer of the Earth is the outer core, which is a molten layer comprised of iron, sulfur, and oxygen. This core makes up 30.8% of the Earth's mass and is a temperature of 37,000 degrees Celsius. The outer core has a depth of 2,000 to 5,000 kilometers. To put this into perspective, the inner and outer core combined is twice as big as the moon. Inge Lehmann discovered the Earth had a solid inner core surrounded by a liquid outer core by studying how the seismic waves bounce off the interior of the Earth. He observed the waves bouncing off the solid inner core and then saw the waves reflected differently off the outer core, suggesting that both of these cores had different states of matter. The motion within the region, along with the Earth's rotation, causes an effect that maintains the Earth's magnetic field. This magnetic field extends outward from the Earth for several thousand kilometers, which gives Earth a protective bubble. Without this bubble, the Earth would be constantly blasted with the sun's solar winds, which would ultimately destroy the Earth's atmosphere, making it dead and lifeless like Mars.
Next layer is the mantle. As we get closer to the Earth, the mantle is the next layer made of iron, magnesium, aluminum, silicon, and oxygen silicate compounds. This layer is a solid but can slowly deform into a plastic manner. The mantle makes up 67.3% of the Earth's mass at a depth of 10 to 2,890 kilometers, with a temperature of around 10,000 degrees Celsius. Waves tell researchers whether the mantle is more or less dense than on average, hotter or cooler than average, and whether it is rising and falling. The mantle is largely hidden from our view, but we see it rise in certain places where the molten rock escapes. These places include volcanoes. The Earth's tectonic plates float on the top of the mantle. Some places the plates slide under one another, and in other places the plates spread apart. This spreading apart is where the molten lava from the mantle breaks through and fills the volcano.
Is the crust. There are two types of the crust, oceanic and continental. This layer is made up of calcium and sodium aluminum silicates and makes up 0.47% of Earth's mass. The crust layer is rocky and brittle with a depth of 0 to 50 kilometers and a temperature of 0 degrees Celsius. The crust often breaks during natural disasters such as earthquakes. The plates float above the Earth's mantle, and it's believed that convection of rock in the mantle causes the plates to slide around. On average, rocks in the crust last about 2 billion years before they slide underneath another plate and are returned to the Earth's mantle. New rocks are formed in the mid-ocean regions where new material wells out of the Earth in between spreading plates. In comparison, rocks in the ocean are only 200 million years old. Seismic waves move through and around the Earth. These waves helped us to determine the structure of the inner Earth as well as to measure earthquakes. The first kind of wave is the P wave, or primary wave. This is the fastest kind of seismic wave and consequently the first to arrive at a seismic station. The P wave can move through solid rock and fluids like water or the liquid layers of the Earth. It pushes and pulls the rock it moves through, just like sound waves push and pull the air. P waves are also known as compression waves because of the pushing and pulling they do. Subjected to a P wave, particles move in the same direction that the wave is moving in, which is the direction that energy is traveling in, and sometimes called the direction of propagation. The second kind of wave is an S wave, or secondary wave, which is the second wave you feel in an earthquake. An S wave is slower than a P wave and can only move through solid rock, not through any liquid medium. It is this property of S waves that led seismologists to conclude that the Earth's outer core is liquid. S waves move rock particles up and down or side to side, perpendicular to the direction that the wave is traveling. Next, we will introduce some natural disasters and see how these are caused by the different layers of the Earth. We will begin with an earthquake. An earthquake is what happens when two blocks of the Earth suddenly slip past one another. The surface where they slip is called a fault. A fault is a crack in Earth's crust. Typically, faults are associated with or form the boundaries between Earth's tectonic plates. In an active fault, the pieces of the Earth's crust along a fault move over time. This moving of rocks causes earthquakes. The crust and the top of the mantle make up a thin skin on the surface of our planet. But this skin is not all in one piece. It is made up of many pieces like a puzzle covering the Earth. Not only that, but these pieces keep slowly moving around, sliding past one another and bumping into each other. We call these puzzle pieces tectonic plates, and the edges of these plates are called plate boundaries. The plate boundaries are made up of many faults, and most earthquakes occur on these faults. Since the edges of the plates are rough, they get stuck while the rest of the plate keeps moving. Finally, when the plate has moved far enough, the edges unstick on one of the faults, and there is an earthquake. The location below the Earth's surface where the earthquake starts is called the hypocenter, and the location directly above it on the surface of the Earth is called the epicenter. Sometimes an earthquake has foreshocks. These are smaller earthquakes that happen in the same place as the larger earthquake that follows. Scientists can't tell that an earthquake is a foreshock until the larger earthquake happens. The largest main earthquake is called the main shocks. Depending on the size of the main shocks, aftershocks can continue for weeks, months, or even years. While the edges of the faults are stuck together and the rest of the block is moving, the energy that would normally cause the blocks to slide past one another is being stored up. When the force of the moving blocks finally overcomes the friction of the rough edges of the fault and it unsticks, all that stored up energy is released. The energy radiates outward from the fault in all directions in the form of seismic waves, like ripples on a pond. The seismic waves shake the Earth as they move through it, and when the waves reach the Earth's surface, they shake the ground and anything on it, like our houses and us. Earthquakes are recorded by instruments called seismographs. The base of the seismograph shakes too, but the hanging weight does not. Instead, the spring or string that is hanging from absorbs all the movement. The difference in position between the shaking part of the seismograph and the motionless part is what is recorded.
Let's talk about the size of an earthquake. It depends on the size of the fault and the amount of slip on the fault. But that's not something scientists can usually measure with a measuring tape, since the faults are many kilometers deep beneath the Earth's surface. So how do they measure an earthquake? They use seismograms recordings made on a seismograph at the surface of the Earth to determine how large the earthquake was. A short wiggly line that doesn't wiggle very much means a small earthquake. A long wiggly line that wiggles a lot means a large earthquake. The length of the wiggle depends on the size of the fault. The size of the wiggle depends on the amount of the slip. The size of the earthquake is called a magnitude. There is one magnitude for each earthquake. Scientists also talk about the intensity of shaking from an earthquake, and this varies depending on where you are during the earthquake. So to give some real-life examples of earthquakes, there was one major one in Nepal, with a magnitude of 7.8. It destroyed buildings and injured thousands of people. The death toll rose up to over 4,000, with almost 8,000 injured. Nepal and the surrounding areas have continued to experience aftershocks. Thousands in the capital of Nepal have spent nights outside because they're afraid to go in their houses because of the aftershock. Water, food, and electricity are short in supply. There are fears of outbreaks of diseases. According to initial estimations and based on the latest earthquake intensity mapping, 8 million people in 39 districts have been affected, of which over 2 million people live in the 11 severely affected districts. This just shows how greatly a natural disaster such as an earthquake affects this world. Another example was in Haiti. There was an earthquake with a magnitude of 7, which was west of the capital city, and there were 52 aftershocks, estimating around 3 million people were affected.
The next natural disaster we'll tell you about is volcanoes. How are volcanoes formed? Volcanoes are formed when magma from within the Earth's upper mantle works its way to the surface. Areas along the edges of the plates are prone to this occurring. When the pressure of dissolved gases build up, an eruption occurs. Gases and rocks shoot up through the opening and spill over or fill the air with lava fires, lava flows, and ash deposits. Over time, as the volcano continues to erupt, it will get bigger and bigger. There are 3 different stages of volcanoes: active, dormant, and extinct. An active volcano is one which has recently erupted, and there is a possibility that it may erupt soon. Most of the 550 active volcanoes are found along the edges of the Earth's plates. A dormant volcano is one which has not erupted in a long time, but there is a possibility it could erupt in the future. An extinct volcano is one which has erupted thousands of years ago, and there is no possibility of eruption. Why do volcanoes erupt? The Earth's crust is made up of huge slabs called plates, which fit together like a jigsaw puzzle. Sometimes these plates move. The friction causes earthquakes and volcanic eruptions near the edges of the plates. In 2010, a volcano in Iceland erupted. Although relatively small for volcanic eruptions, it caused enormous disruption to air travel across Western and Northern Europe over an initial period of 6 days in April 2010. About 20 countries closed their airspace and commercial jet traffic, and it affected about 10 million travelers.
The third natural disaster we're covering are tsunamis. Tsunami is a word that originates in the Japanese language and means seismic sea waves. Tsunamis are often incorrectly interchanged with the term tidal waves, which refer to high waves of water caused by changes in flow and surge of the ocean. Tsunamis, on the other hand, can be caused by a few different means. The down drop of upthirst of Earth's crust, which results in an earthquake, a large-scale undersea landslide, a submarine volcanic eruption, or potentially a large meteor impact of the sea. The vast majority of tsunamis come from earthquakes. One major tsunami that occurred recently was in Japan, and it came from a magnitude 9 undersea earthquake, and it led to tsunami waves that reached 133 feet. There were over 15,000 deaths, 6,000 others injured, and almost 3,000 other people went missing. 127,000 buildings collapsed, and many, many more half collapsed and were partially damaged. The earthquake and tsunami also caused extensive and severe structural damage in northeastern Japan, including damage to roads, railways, and caused fires and dam collapses. Over 4 million households in northwest Japan were left without electricity and millions others without water. This also led to several nuclear meltdowns. So this just goes to show as well how damaging this type of natural disaster can be.
Now we're going to talk about how earthquakes cause tsunamis. A subduction earthquake is one where a denser plate shifts below its neighboring plate. Energy is transferred, and the displaced water forms a wave. As the wave travels and enters shallower water in the coastal area, it begins to increase in amplitude. Tsunamis are not always colossal waves when they come into the shore. In fact, most tsunamis do not result in giant breaking waves, and instead come in very strong and very fast tides. Nevertheless, there is a destruction of life and of property by floating debris and impact of water. The tsunami produces a series of rushing waves and also a series of withdrawal. And now, how volcanoes cause tsunamis. There are 2 different ways a volcano can cause seismic waves. One possibility is for land-based volcano to break down and collapse, forcing large amounts of ash debris into the water. This sudden change in displacement of the water column transfers to kinetic energy and results in waves. More debris can create a bigger increase in wave amplitude and number. Tsunamis can also be induced by submarine volcanoes. These underwater volcanoes can collapse downwards and spew forth lava, heating the surrounding water quickly.